Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For the Honorable our reviewers, for the Honorable our supervisor, Mr. Darat Pramandihanto from Computer Engineering Polytechnic Elektronika Negeri Surabaya, and Mr. Ali Ridho Barakwa from Informatics Engineering Polytechnic Elektronika Negeri Surabaya. Today, we would like to present about our papers with title Flow Vision, Object Recognition and Post Estimation System based on three-dimensional computer vision. First of all, let me introduce ourselves. My name is Farjan Saya Pratama Harsada Putra from Computer Engineering Polytechnic Elektronika Negeri Surabaya. With our supervisor, Mr. Professor Engineer Dadat Pramadihanto, Magister Engineering PhD from Computer Engineering Polytechnic Elektronika Negeri Surabaya, and Mr. Ali Ridho Barakbah, Sarjana Computer PhD from Informatics Engineering Polytechnic Elektronika Negeri Surabaya. The next one is table of content. In this section, there are including the background, design system, processing point cloud data, centered object estimation, orientation object recognition, and the last one is conclusion. And then the next one is background. So what is the main idea of this paper? The main idea of this paper is detecting object, gripper, and pose of object for developing vision system of deep-flow humanoid robotics. So the purpose of this paper is searching an algorithm for detecting object, gripper, and pose of object from several datasets. And the function of this paper for the future is the system can be implemented to vision system of deep-flow humanoid robotics. And then this is our design system. There are four sections of this design system. The first one is RGBD acquisition, and then pre-processing data, and then processing data, and the last one is detection. From RGB acquisition, there are hardware setup to RGBD capture, and then pre-processing is in non-measure points filter or non-filter, and then move to crop filter using conditional removal. And the next step is plane segmentation using Ransack algorithm. And then the next step is noise outlier filter. And pasti udah. In this section, yes. And then this is our design system. In this design system, we have four steps of our research. The first one is RGBD acquisition, and then pre-processing data, and processing data, and the last one is detection or recognition. And in RGBD acquisition, there are hardware setup, RGBD capture, and then move to pre-processing. There are non-measure points filter or non-filters, and then crop filter, and then we moving again to plane segmentation using Ransack algorithm, and then we move back to pre-processing that for noise outlier filter, and then we using Euclidean extraction for separate the object and gripper, and then we move to detection that are object and gripper normal estimation, and then move to object gripper centered calculation, and then we move again to pre-processing data that object and gripper and scene feature extraction using shot estimation, and then after feature extraction, object and gripper and scene descriptor matching from each feature extraction, and then the last one is visualization of object and gripper direction, and the last step is object post estimation using Ransack and visualization. This is our processing point cloud data, and there are object orientation from 0 degree until 150 degree. In this table, there are scene data, group data, segmentation data, filter noise outlier data, cluster data, and then the last one is normal estimation. This is for processing workload data. In scene data, we are collecting the data set. After we collecting the data set from each object orientation, we are grouping the data to focusing the object and the gripper. And then we segmentation for the planner, for removing the planner using Rorschach algorithm, and the result is like in this slide. After we segmentation the planner, there still have a noise of outlier, and then we must remove the filter, the noise outlier using filter, and the result is in column filter noise outlier. After we removing noise outlier, the next step is cluster data. Cluster data, the function of cluster data is separate the object and the gripper. And last one is normal estimation for searching the surface of object and gripper. So after we found the normal estimation, we can search the central object estimation from object 0 degree until object 150 degree. That we measure in actual position or real position that are px one, the px is 10, the py is 100, and the pz is 600. Or how bingung kalian? Px itu apa sih? Oh ya. Okay. After we found the normal estimation for object and gripper, now we need to search the central object estimation for object only from 0 degree until 150 degree. And there are actual position and estimation result. The actual position is 10 millimeter, and then 100 millimeter, and 600 millimeter in px, py, and pz. And the estimation result, there are some error in estimated error absolute. For object 0 degree, there are 10 millimeter, and then for py, the error absolute is 10 millimeter too, and the pz is, the error absolute is 20. And we can search the error absolute from actual position subtract with estimation result. And the next one is the result of orientation object recognition. In this slide, this is the result of object detection, gripper detection, and post detection with side. Okay. And then the next step is orientation object recognition. In this section, we have the result of object detection, gripper detection, and post detection for each degree from 0 degree until 150 degree. And for the object detection, we can search the object with 100% 100% work perfectly. And then the gripper detection, we know the gripper can detect with 100%. Oh, shit. And the next slide is orientation object recognition. Uh, in this slide, this is the result of object detection, gripper detection, and push detection for each degree from 0 degree until 150 degree. And there are five trials for testing for 0 degree until 150 degree. And for each trial, if the trial is success, the if the trial is success, the percentage of success with is the next slide is orientation object recognition. In this slide, there are the result of recognition object and then object detection, gripper detection. Apa sih jancuk? The next slide is orientation object recognition. In this slide is have the object detection, gripper detection, and push detection for each degree from 0 degree until 150 degree. We have 5 trials for each detection, and if one trial is success, maybe the object detection one in degree 0 is success, we can calculate that uh, one trial have the value 20% of success. And in this slide we have success all of it, and we can conclude that we have 100% for object detection, gripper detection, and push detection. So last one is conclusion. So what is the conclusion of this paper? That after we found the after we research this data, the point cloud data can be processed accurately with percentage 100%, and then the system works perfectly on offline processing or static processing, and then system can be segmented and clustered correctly with percentage 100%, and then object and gripper detection work perfectly with percentage 100%. And the last one is post estimation of object. For each object, orientation can work perfectly with 100%. Thank you for your attention. Time and place we're giving back to moderator.